Alright, for our next video I want to get into the next set of identities called the Pythagorean identities. And before we just jump into some problems, I just want to go back and revisit where we are coming from here. If we were to have a certain angle in our unit circle, and we could call this our reference angle right here. And of course we can create a perpendicular line and create our little triangle. So if we were looking at this triangle and I were to tell you that we had two known sides, could we find the third missing side of this triangle that we created? You of course would say yes. Well, we know this part of this triangle is the x value, and we know that is also referred to as the cosine, and we know this part is the y value of the triangle, and we know that is also the sine value, and we know this hypotenuse is what we've referred to as the r, or radius, of our circle. So using this, we should be able to say that the cosine value, which is one of the smaller one of the legs of the triangle, and if we were to square that value and add it to the square of the sine, that should be equal to the radius squared. And of course, again, this is our Pythagorean theorem. Oops. So we're just going to take this one more step. In our unit circle, we know that r is the radius of our unit circle, which is 1, and so 1 squared is 1. So we're going to finish up with the Pythagorean identity, which says that the cosine squared plus the sine squared is equal to 1. So that's where that comes from. A couple others that I want you to write down that are just takeoffs from this are the tangent squared plus 1 is equal to the secant squared. And one more I want you to write down: the cotangent plus 1 is equal to the cosecant squared. So these are the three that you want to have written down and be available to use as we work with the Pythagorean identities. Alright, so here's the first problem that we're going to try out together. It says if the tangent were equal to -8, and we know that the sine of the angle is greater than 0. So what does that mean? Greater than 0. Of course, that means that the sine is going to be positive. And they want us to find the sine and the cosine values. So just thinking a little bit ahead here, if the tangent is -8 and the sine is greater than 0, we know that the sine value must be positive. So if the tangent is negative and we know the sine is positive, what do we know about the cosine? Of course, we know that the cosine must be negative. So which of the three Pythagorean identities that we wrote down is going to work best for this problem? Well, we're given the tangent, and we do have the tangent squared formula. So let's go ahead and start with that. That is the tangent squared plus 1 equals the secant squared. So from this, let's start putting in what we know. We know that the tangent is -8. We were given that, of course, from the problem, and we're going to square it. Plus 1 is equal to the secant squared. Well, the secant squared we do not know yet, so we're going to leave it as is. Now we know that -8 and we probably should put that in parentheses there. Negative 8 squared is, of course, 64, plus 1 is equal to the secant squared. And I'm going to get this out of the way there. We shouldn't have that. And 65 equals the secant squared. And what would we do at this point? Of course, we want to find out what the secant is. We would take the square root of both sides, and that tells us that the secant is going to be equal to the square root of 65. Alright, now we need to find the sine and the cosine. So if the secant is equal to the square root of 65, what is the inverse function of secant? Well, of course, that is cosine. So we know the cosine is going to be the equal to the inverse of this. So cosine is going to be equal to the inverse of the secant. And hopefully you're thinking we don't want to leave that radical in the bottom. So we multiply it by the square root of 65 over square root of 65. And we end up with the square root of 65 over 65. Now, remember that we said that because the sine was positive and the tangent was negative, the cosine must be negative. So we know that the cosine must be negative square root of 65 over 65. Alright, before I leave this little negative sign, I just wanted to add that you may remember when we take the square roots of numbers, the result of that can either be positive or negative. In other words, the square root of 65 times the square root of 65 is 65, or a negative square root of 65 times negative square root of 65 is 65. So we have both possibilities there, and because of the information given at the beginning of the problem, we know that the cosine must be the negative of the two and not the positive. Now the rest of our problem is to solve for sine. And at this point in time we just can go back to the very basics. We have the tangent, and we know that the tangent is equal to the sine over the cosine. And we've been told that the tangent is equal to negative 8. And we know the sine is still a mystery, and that is over the cosine, which is what we just found out, which is negative square root of 65 over 65. Now if we cross multiply these two values, let's see if we can squeeze us in here. We come out with the sine is equal to, and again we're multiplying, cross multiplying right here, so we have negative 8 times the negative, so we know that's going to be positive 8 times the square root of 65 over 65. And we're looking to see if we have any common factors, and we do not. So our answer for the sine is 8 times the square root of 65 over 65 right there. Yeah, I like this red. It shows up pretty good. Alright, so we started with knowing that the tangent was negative, the sine was positive, so that told us the cosine must be negative. We used one of our Pythagorean identities to solve for the secant, which we then figured out the cosine, which was the inverse, and then we plugged that back into our very basic formula of tangent equals sine over cosine, and that was our quotient identity, and then used that to solve for sine, which we came out to again 8 times the square root of 65 over 65.